How are you
Hello,
doing?
Mr. Nourizian.
Pleasure to meet you,
Nice
sir.
to meet you.
Hi, sir.
Have a seat, please.
Sure.
I'm going to go over a few questions and then we want to get to know you better.
For
a
sure.
little bit. What is biomedical engineer, if you could tell me, please?
For sure. Great question. So, pretty much the job of a biomedical engineer entails mainly designing various systems and products that are correlated to both biology and the medical fields. As an engineer, they help to develop products such as artificial organs, devices that suffice for body parts such as prosthetics, and or machines that can help to diagnose whether someone has a medical problem or not. Furthermore, biomedical engineers fix, develop, adjust, and or research to aid biomedical equipment and technologies that we use in our everyday lives.
Very interesting. Can you please tell me what sort of education is required to be a biomedical engineer?
For sure. So myself, I studied at Highland Secondary School at the time. I know we haven't heard of that school. I took all the university courses that were prerequisites at the time, which was, there were 6 URM courses. I took English 4U, I took Advanced Functions, Calculus and Vectors, Chemistry 4U, and Physics 4U. Then because I wanted to go to McMaster at the time, I needed over 85 average to get in. And class of 90, I know I might not look 50 years old, but yes, I'm approaching that mark. The courses I needed to take, in which it took me 4 years to acquire my degree, a biomedical bachelor in biomedical engineering, undergraduate. I took courses which included engineering physics, mechanical engineering, electrical engineering and design courses, mathematics, thermodynamics, manufacturing engineering, as well as an addition of biology and chemistry courses such as cellular and molecular biology for my biomedical field.
Oh, I see. What sort of relation is there to physics when you take biomedical engineering?
It's a very good question, actually. So, just like any other type of engineering, biomedical engineering is greatly associated with physics. Since engineering is pretty much an application of physics and mathematics into the real life, biomedical engineering works with basics of mechanical movements in physics behind different technologies we use in our biomedical industry. They work with MRI machines, magnetic fields, and pacemakers, which work with electrons and involve physics, because the engineers need to see how the electrons and electricity helps operate the product. For prosthetics, it requires movement, so mechanical aspects of biomedical engineering is used to develop the prosthetics and make sure they work. But pretty much an engineering thinking causes physics electrons to move.
Very interesting. Can you give me specific examples, please?
I can give you 2 specific examples of many. Biomedical engineering is used in developing artificial corneas. I'm not sure if you're very familiar with them, because it uses optics, mirrors, reflections, and refractions, theory of lights, and movement, which are all branches of physics. Also, manufacturing an artificial cornea is done by applying polymer physics, which is using synthetic materials to make the artificial cornea. Since the cornea focuses light into the lens, one single beam, it uses optics, which is a strand of physics and which covers behaviors and properties of light to make it. Another example I could give you is pacemakers is something I work with, and how biomedical engineering incorporates this very, very exquisite product, physics, when we work with them. Pacemakers are pretty much used to regulate the heart rate for some people who may have problems, and by using electrical impulses to contract the muscles around the heart and cause it to beat. Therefore, pacemakers are electricity, which is a branch of physics. I'm sure you're probably aware of it. There's a current, which is the rate at which the electricity flows through the surface in contact, and there is an energy created that can be stored in the pacemakers, which allows for a maximum energy to be stored in the heart. So if the heart were to skip a beat, the energy can be released in the form of electrical pulse and allow the heart to beat. So those are just a few things I can name for you. Was there any other questions you had for me?
That's a very interesting subject, and thank you for all the information.
If you have any other questions, you have my number. Please feel free to call me.
Sure, we'll be in touch.
It was a pleasure. Thank you very much.
No problem.